Hi everyone, I am Naila Raswan, and it's great to be here today to talk about one of the most exciting technologies behind the AI revolution, neural networks. Have you ever wondered how Netflix recommends shows you love, or how self-driving cars recognize pedestrians and street signs? The magic behind this is neural networks, which are modeled after the human brain's ability to learn and process information. So in today's seminar, I'll explain what neural networks are, how they work, and discuss their applications in today's world. A neural network, it's a type of machine learning model inspired by the structure of the human brain, where neurons are connected to each other to process information and make decisions. The basic structure of a neural network includes, of course, first and foremost, neurons or nodes. These are the basic units in a neural network, which is actually inspired from the biological neurons. These nodes take input, perform calculations, and pass the output to the next layer, which is the next basic structure, that is layers. There are three different layers in a neural network. One is input layer. This is where raw data is fed into the network. Second is hidden layer. These intermediate layers perform calculations and detect patterns within the data. And finally, the output layer. The final result or prediction is produced in the output layer. So why do these neural networks matter? They are really good at handling complex tasks like image recognition, natural language processing, and even gameplay, where traditional algorithms struggle. Next, let's see how these neural networks work. First one is forward propagation. In forward propagation, data passes through the layers of the network. Each node applies a mathematical function like a weighted sum to the inputs and the result it's passed forward. If I had to give you an example, in an image recognition task, the input layer could represent pixels, and as the data moves through the hidden layers, the network learns features like edges, shapes, and eventually complex objects like faces or cars. Next is activation function. And this is what decides whether a neuron should fire or not, mimicking how neurons in our brain activate. And finally, learning with back propagation. Neural networks learn by adjusting the weights between neurons. After making a prediction, the network calculates the error by comparing the predicted result to the actual result. So back propagation is the process of sending this error back through the network and updating the weights to reduce future errors. So learning rate controls how much the weights change after each iteration. Next, let's see what are the different types of neural networks. Number one is feed-forward neural network. They are the simplest form. Data moves only in one direction, from input to output. And they are often used for classification tasks like image recognition and speech recognition. Number two is convolutional neural networks. They are specifically designed for processing grid-like data, like images. They use filters to automatically detect patterns such as edges, textures, and shapes. And they are widely used in computer vision tasks like object detection, facial recognition, and medical image analysis. Number three is recurrent neural networks. And they are used for sequence data because they have loops allowing information to persist. They can handle tasks where context and previous information matter. commonly used for language translation, speech recognition, and time series prediction. Number 4 is generative adversarial networks. These consist of two networks, a generator and a discriminator, competing against each other. The generator creates fake data and the discriminator tries to distinguish between real and fake data. They are used for generating realistic images, videos, and even artwork, and they have been instrumental in fields like entertainment and fashion. Finally, let's see what are the different applications or real-life applications of neural networks. Computer vision. Neural networks are used in facial recognition systems, self-driving cars, and medical image analysis, where they can identify tumors or detect diseases. The impact being that they help automate tasks which were previously only possible through human visual inspection. Second one is natural language processing or NLP. Neural networks they power virtual assistants like Siri and Alexa. They translate languages and even generate text as seen in chatbots or content creation. The impact is that they have transformed how machines understand and interact with human language. Third application is in healthcare. Neural networks are being used to predict patient outcomes, analyze medical records, and even design personalized treatments based on individual health data. The biggest impact is that AI-driven diagnostics and treatment plans are making healthcare more precise and accessible. So to conclude, neural networks are the driving force behind modern AI, enabling machines to see, hear, and understand the world in ways that were once thought impossible. As neural networks continue to evolve, they are set to disrupt industries ranging from healthcare to finance. And now is the time to understand and explore their potential. Thank you so much for your time, and I hope this session has provided with you a much better understanding of neural networks and their transformative role in technology. Thank you so much for your time. See you next time.